Welcome learners. Welcome to this session on Relational Database Management System. Let's begin this module. This is a brief outline of this module. We will be starting with database structure and schema. Then we will cover what is data independence. We will see various types of data independence. We will see some terminologies that we are using in RDBMS. And lastly, we will use data dictionary. Let's begin. Database structure or database schema. In DBMS terms, schema is nothing but actually the design or the structure of a database. So database schema is basically the structure of the database. Here, the overall structure of a database is called a database schema or simply schema. It is nothing but a physical representation of data that appears in database management system. Here what we have defined it on three levels. First, a logical level. Second, a view level, and finally we have the physical level. So at logical level we have logical schema, then we have the conceptual schema, and finally we have this physical schema. And these are connected to different views that forms the view level schemas. Now, schema of a database does not change by performing certain operations such as insertion, updation and deletion because it is concerned with the structure. So whatever changes you make in the data, it doesn't reflect on the schema. But if you modify or change the structure, that change is visible to all the things. Database schema describes the integrity constraints, database constraints, domains of all the attributes, foreign and primary key of all the relations. Now we will see various types of database schema we have. So we basically classify database schema as physical schema, then we have logical schema, and we have the view schema. At the physical schema, the main characteristics of physical schema are, it represents how the data is stored on the disk because as the name suggests, this is a physical schema, so it is somewhat related to the physical storage of the data which is in the form of disks. So it represents how data is stored on the disk storage or the data target where you want to store the data finally. It is the lowest form of abstraction because all these levels of schema offer some kind of abstraction in data and data storage as well as a retrieval. So it is the lowest form of abstraction. It acts as a foundation for other types of schemas to create relationships and indices. So we can do indexing in the data stored so that we can get the data in a small amount of time. It usually indicates the storage location which is defined in terms of GBs and TBs because here we are using disks. So we measure the capacity of disk on the basis of how many gigabytes or terabytes can be stored. So here we measure it in terms of GBs and TBs. Now it is the logical schema. The logical schema represents the conceptual or the logical model of the database. It is primarily focused on the business entities. That means what all real world entities we want to store in the database, we model the data accordingly and we create relationship among those tables that we have created to store the data. At the logical level, the data is stored physically and is illustrated as various attributes. For example, if you want to store the data of a student is a real world object or an entity, but we identify a student on the basis of certain attributes, not directly by its value. So it is a combination of say enrollment number, roll number, name, class and many other attributes. And DBAs, that is the database administrators and specialized database programmers work at this level. Then we have the view schema which is also known as the external schema because it is this schema or the overall design which a normal user is aware of and it is that view which is shown to the normal or the end users. It is generally described by the user's interaction with the database system because in order to interact with the system you need to have some kind of interface and that interface design is done using the view schema. Then we have at the view level, a user can interact with the system using an interface, for example, a form. If you want to book a ticket online, what you do, you don't access the database directly, you access this database on the basis of some kind of a form. So that interface comes under the view schema. It provides abstraction as users are not aware of where and how data is stored. It provides a kind of a security so that unauthorized access can be prevented. And actually the end users or the normal users, they work at this level. Let us see the advantages and disadvantages of database schema. The main advantages of having a database schema is that it allows to manage the data independent of the physical storage, because the way we store data physically is totally different with the way we express or represent it on the system. So it provides a kind of a independence of this representation. It provides very faster migration to various graphical environments. It is not always necessary that you represent the data graphically. So whenever it is required that you want to present or you want to print that data graphically, it becomes very easy to migrate your data. Then it also allows users to make changes on the presentation level without affecting the other two layers. That means whatever is the view level representation, you can make any kind of changes. You want to represent data as a graph, you want to represent that data as a table, you want to represent that data in terms of other graphical representations, but the actual data where it is stored is separated from this representation so that accidental loss of data can be prevented. Each tier is separated. That means each level of the data storage is separated. It is more secure because the client does not have a direct access to database. Through an interface, it have the database access so that you can control the access very easily. In case of any failure of one tier, there will be no data loss in the other tiers. These are some of the disadvantages of database schema. First, the complete database schema is a complex structure to implement. For smaller systems, it is not much understandable, but if our system size increases, our complexity of structuring that data is also increased. Hence, for a very big or a complex system, the database schema is a bit tricky one. Then, it is very difficult to understand that particular representation by every user because there are different levels of users that are accessing those database. Then it is difficult to set up and maintain. So to set up or to have a physical organization of such data is a big task, and also to maintain such data is also requiring various measures. The physical separation of tiers can affect the performance of the database. Let us see database independence or data independence. We have two types of data independence. First, the logical data independence, and second, the physical database independence. As the name suggests, the logical data independence is related to logical schema and the physical data independence related to the physical schema. Let us now understand the concept of data independence. Here, the data independence is defined as a property of RDBMS that helps to change the database schema at one level of the database without requiring to change the schema of the next higher level. That means whatever changes you can make, that change can be only on one layer and one tier without affecting the other levels. Data independence is the type of data transparency which refers to the immunity of user applications to changes made in the definition and the organization of data. That means the organization of data and the definition of data are separated using this property or concept. It also helps to keep the data separated from all the programs that may use it. And also the interfaces between the various levels and components should be well defined so that changes in one part do not seriously influence or affect the other parts. We will see the types of data independence now. First, the physical data independence. The physical data independence can be defined as it is a capacity to change the internal schema or the internal design of the database without having to change the conceptual schema. The way you organize your data internally can be totally separated from the way it is logically represented, because we see data in terms of tables, but actually that table is not stored as a table, it is stored in somewhere other form in the physical storage. So it provides you that separation from the physical storage to the conceptual representation. Physical data independence is used to separate the conceptual levels from the internal levels at the logical interface level. Where you provide logical interface, there you implement this physical data independence. Some of the examples are using a new storage device like a hard drive or a magnetic tape, modifying the file organization techniques in database, switching to the different data structures, changing the access method, modifying the indexes, changes to the compression techniques or hashing algorithms, change to the location of database from C drive to D drive. If you change the location, it doesn't affect the data. That means we have separated the organization from the representation. This is called physical data independence. The second type of data independence is logical data independence. Here in logical data independence, it is the ability to change the conceptual schema without external views or programs. In the previous one, we deal with physical and logical. This is conceptual and external. So it is used to separate the external level from the conceptual view. If we do change in the conceptual view of data, then the user view of data would not be affected. It occurs at the user interface level. That means at the external level where the end users interact with the system. These are the examples of it: adding, modifying or deleting any attribute or value of entity or relationship. It does not affect the structure because we are making changes in data, right? We are not changing the structure. Schema means structure. Merging of the two records into one. It also doesn't affect the overall schema, and breaking an existing record into two or more records. So this is logical data independence. Now we will see the differences between logical data independence and the physical data independence. So first is, the logical data independence is mainly concerned with the structure or changing the data definition, but physical independence deal with the storage of the data, where it is actually stored in the physical medium. Second difference is, it is difficult as retrieving of data is mainly dependent on logical structure, but this is very easy. You have one type of representation and it's very easy to get the data from that representation. So it is easy to retrieve. The third difference is, compared to the physical independence, logical physical independence is difficult to achieve. Compared to logical independence, it is easy to achieve because you are directly deal with the storage medium, not with the different logical representations. If new fields are added or deleted from the database, one need to make changes in the application program. That means whatever changes you are making in the structure here, it need to be reflected back to the application program. But change in the physical level usually does not change at the application level, because we are just changing the physical storage, we are not changing the logical representation of data. Modification at logical level is very significant whenever the logical structures of database are changed. So if you change the logical structure, then the modification at logical level is important. Modification made at the internal levels or the physical level may or may not be needed to improve the performance of structure. For example, from using a normal server, you have switched on to a very advanced and a fast server. It doesn't affect your data. So this is physical data independence. Then it is concerned with the conceptual schema, and this is concerned with the internal schema. These are some basic differences between physical independence and logical data independence. Now we will see some RDBMS terminologies that we frequently use. So what is RDBMS? A relational database is a collection of an organized set of tables, or we can say rows and columns, from which data can be accessed easily. This is the most frequently used representation of data, in which we store the data in terms of tables. The RDBMS is a type of DBMS that stores information in the form of related tables and uses a relational model defined by Codd's 12 rules. So there are 12 rules defined by E.F. Codd, which are known as 12 rules of DBMS, and relational DBMS follow these 12 rules. It is not necessary that all the rules is followed. We only strive to have the maximum number of rules followed by a database. And this is the important point. A database is called relational. How do we define a normal database to be a relational database? A database is called relational because the values in each tables are related to each other. There are situations where there are some kind of relationship amongst the table values. So such relationships can be represented using the concept of relational DBMS. Such relationships can be represented using the concepts of relational DBMS. These are the basic terminologies that we use in RDBMS: relations, then we have tuples, then we have attributes, we have domains, and we have cardinality. So these are the major terminologies. So we represent data in terms of tables in a relational database management system, and this is known as a relation. So a table is called a relation. What all values we store values pertaining to different attributes. These fields are known as attributes, or we can say column of the table. And one filled row of information, this is called a tuple. So we have a relation, we have attributes, and we have tuples. A number of tuples together makes up a record. So we can define relation as, a relation is a table in DBMS. It is a grid made up of rows and columns. We just organize data in terms of rows and column, and we call that number of rows or columns as a relation or a table. Then second is tuples. What are tuples? A row in a table is known as tuple or a record. So, a one filled row of values, it is called a tuple. Then we have attributes. Individual pieces of data which we record to store the information about a particular entity are called as attributes. A table can have different attributes. Then we have domains. What are domains? Domains are all possible allowed values. For example, if we want to keep our age of a student from say 16 years to 21 years of age, so we have made this as a foundation that whatever value is allowed in that particular field should follow that condition. So this is a set of allowed value. That means age can be 16, 17, 18, 19, 20 or 21, not more than 21 and not less than 16 is accepted. So all the allowed values of attributes are known as domain. Then cardinality. The number of tuples or records in a relation is called cardinality. What all number of records or tuples you have in a relation are called cardinality. Now, some attributes have a wide range of different data values, because since we are storing the data in different columns, so there may be chances that we have a wide range of different data values. So where there is a large percentage of n, it is very important that we should have unique values here. If we have large number of unique values, we say that we have high cardinality, and if we have less number of unique value, we say that it is a low cardinality. Now we come to a very important topic, it's called data dictionary. Now what is a data dictionary? Data dictionary can be defined as a DBMS component which stores the definition or the characteristics of data and relationship. It tells you about data, or we can say that data about data. It is also called data about data, and most importantly, this is a term which we associate with data dictionary. It's called metadata. Metadata means data about data. Data dictionary provides DBMS with its self-describing characteristics, because it is not at all necessary that whosoever is created that DBMS needs to update it always. So we should have a knowledge of about the fields, of about the different values, their types, their domains. So all this additional information about data is called data dictionary. We store it somewhere, and that area is called a data dictionary. For example, we have this data. So we have an employee ID, first name, last name, number and department ID. Now this is the data table, but data dictionary or the metadata is data about this data. For example, this is the column is employee ID. It is having a type as integer. The description is this is the primary key of the table. We will be covering keys and other things in the subsequent modules. Then first name. What is first name? Its data type, its description. So all this thing describes what all information we need to store in that table. So this is called data about data. So this is called data dictionary. Let us see what we have covered in this module. We started with what is a database structure or a schema. Then we have covered data independence, both the physical independence as well as logical independence, and also seen their differences. We have covered basic RDBMS terminologies like tuples, relation, attributes and all. And we have seen what is a data dictionary. I hope this session is beneficial for you. Thank you for joining.